sphere of mass, this is sphere, the mass say m1, 47 kg. A sphere of aluminium is there, mass itne at temperature 100 degrees Celsius is transferred into copper calorimeter. This is a copper calorimeter. Copper containing M2, water 0.25 kg. At temperature 20 degree Celsius attains steady state. ये ट्रांसफर कर दिया इसमें T temperature of mixture it is 23 degrees Celsius. Calculate specific heat capacity of aluminium. Mass of copper calorimeter, say M2, it is 0.14 kg. Again, aluminium sphere, this is the mass, this is temperature, specific heat unknown, we have to find it is transferred in this. This is a copper vessel calorimeter, mass is this, temperature of water is 20, so copper is also 20, and mass of water is this. Loss in temperature for aluminium, it is T1 minus T, 100 minus 23, it is 77 degrees Celsius. Gain in temperature for water as well as calorimeter vessel, copper calorimeter. Their temperature was this, mixture was this, so it is T minus T2, it is 2 degree Celsius. Heat lost is equal to heat gained. Heat lost by aluminium, MCT. What is M here? M1. What is C? C1. What is T? Falling temperature. Heat gained by water, MCT, 2 T. It is T minus T2 plus MCT, heat gained by copper calorimeter. It is M3, it is C3, it is T minus T2. This we have to calculate. Other things are given. This is C2 given, specific heat of water. C3, specific heat of copper, it is given. M1, 0.047. C1 we have to calculate. T1 minus T, fall in temperature, it is 77. M2, mass of water 0.25. C2, specific heat of water 4.18 10 की 3. T minus T2, fall, it is 2 plus M3, mass of copper calorimeter. This is M3, mass of copper calorimeter 0.14. C3, specific heat of copper 0.362 10 raised to power 3 into 2. Or C1, multiply this and solve. It is 3297. One two by, solve it by 0.047 into 77, and C1 comes out to be joule per kilogram per Kelvin inverse. Rise in temperature, a fall in temperature, degree Celsius inverse. Kelvin inverse, fall, rise, same, whether it is in CGS, whether it is in Kelvin. So this is C1, specific heat of aluminium. What we have to do? Heat lost कौन करेगा? ये ज़्यादा टेम्परेचर कौन गेन करेगा? वाटर प्लस. So MCT is equal to MCT. MCT by water, MCT by calorimeter. Rest calculations. calculate heat required to change 1 kg of ice at minus 10 degrees Celsius to steam at 100 degrees Celsius, given specific heat ice 0.5 calorie per gram degrees Celsius inverse. Specific heat water 1 calorie per gram degree Celsius inverse. Latent heat ice 80 calorie per gram. Latent heat steam 540 calorie per gram. Most of units are CGS. Now mass 1 kg 1000 gram. It is at minus 10 degrees Celsius. We have to change its steam into 100 degrees Celsius. Given is this. Heat required to change minus 10 degrees Celsius ice into 0 degrees Celsius ice. It is MCT. M 1000 C 0.5 ice T falling temperature 10 point with this 10, so this much calories. Heat required to change 0 degrees Celsius ice into 0 degrees Celsius water. Change of state, it is ml. M 1000 L ice 80 840 calorie. Heat required to change 0 degrees Celsius water into 100 degrees Celsius water. It is MCT. This is rise in temperature. M 1000 C water 1 T 100 calories. Heat required to change 100 degrees Celsius water into 100 degrees Celsius steam. Again, no change in temperature, so latent heat M L total heat required to change 10 degrees Celsius ice into 100 degrees Celsius steam. Calorie plus calories plus plus now add them, 3 zeros, 8, 5, 13, it is 5, it is 6, calories. If you want to change it in joules, multiply it 4.2. Find specific heat of metal block of mass this, temperature this, drop to copper calorimetry, water equivalent is given. Main thing, water equivalent always in grams, never in kilograms. So change all in CGS units. Metal block. What is given for metal block? Mass 0.2 kg. 0.2 into 1000, it is 200 gram. T1, temperature 150 degrees Celsius. Find specific heat. C1 we have to calculate. Now for copper calorimeter, water equivalent 0.025 kg, it is 0.025 into 1000, 25 gram. Mass of water M2, it is rho v. Density, mass upon volume, density 1, volume 150, it is 150 gram. Specific heat, water, say 2 gram. Calorie per gram degree Celsius inverse. Water temperature 40 degrees Celsius. Loss in temperature for metal T. Temperature of mixture, and it is final temperature is 40. This temperature of water and calorimeter is 27. Loss in temperature of metal T1 minus T, it is 150 minus 40, 110 degrees Celsius. Gain in temperature for water plus calorimeter, it is T minus T2, 40, 27, it is 13 degrees Celsius. Heat lost, metal block. Heat gained, water plus calorimeter, MCT, metal T, fall in temperature T1 minus T, heat gained, MCT, T, gain in temperature, T minus T2 plus WT, T minus T2. This is heat gained by water, this is heat gained by calorimeter. M1 C1 we have to calculate fall in temperature. M2 mass, it is 150, C2 1, fall in temperature, it is 13 plus water equivalent 25 into 13, it is 13 common 150 plus 25, 13, 175 C1 13 into 175 by solve it. Zero point 1 calorie per gram per degree Celsius. Is this specific if heat loss due to surrounding is negligible? Is not negligible. This is specific heat when no loss of heat due to surrounding. If there is loss of heat also due to surrounding, then that heat will be added here. Loss of heat. So specific heat is less than actual value if there is loss of heat due to surroundings. Zero point 0.15 kilogram of ice at 0 degrees Celsius is mixed with 0.30 kg of water at 50 degrees Celsius. Resulting temperature is 6.7 degrees Celsius. Calculate latent heat of fusion of ice. Specific heat water 4186 joule per kg per Kelvin. Ice M1 0.15 kg, T1 0 degree Celsius, L we have to find water M2, it is 0.30 kg, C 4186 joule per kg per Kelvin, T2 50 degrees Celsius, temperature of mixture, that is T 6.7 degrees Celsius, fall in temperature, for water, it is T2 minus T, it is 50 minus 6.7, it is 3 degrees Celsius. Gain in temperature for ice, the temperature of ice is T, T1 of mixture it is T, so T minus T1 it is 6.7 minus 0, 7 degrees Celsius. Heat gained by ice ml, 0 degree ice to 0 degree water, then MCT. What is M? M1. C is C. What is T? Heat gained by ice, so gain in temperature. This is that T. M1 0.15 into L, 0.15 C, 4186, T minus T1 6.7, heat lost by water is MCT. M2, C water is CT. Fall in temperature, this is that T. M2 for water 0.30 C. Specific heat 4186 into 43.3. Now heat gained, heat lost. This is principle of calorimetry. 0.15 L plus 1586.6.7 is equal to 0.304186 43.3. 0.15 L 0.304186 43.3 minus, take this to this side, 4186 into 6.7, or L comes out to be 304186 43.3 1.5 4186 6.7 by 0.15. This was 0.15. So it will be cancelled. Here it is 2. So 4186 common. It will be 243.3 minus, here cancel. This is common, 6.7. 4186 668 plus 6.7. It is 393. Solve it. It will be 3.345 joule per kilogram.